That's okay. It's hard to understand technology, so.
Exactly, yeah.
All right.
So I have a couple new ones, different ones that I think I just sent you in picture, if you'd mind looking that up.
I can certainly do that, but I would like to go over the two problems that I got wrong last time, if you don't mind.
Okay. Surely.
One was number 2.
Yes.
All right. Here's what we have for number 2. That's the master equation.
Yes.
And the rate of the boat, this was kind of an optical illusion type math problem.
Uh-huh.
Really was. It took me a long time to get this. I finally figured it out.
Good. Good.
The distance when it's going downstream, which is 48 miles downstream.
Yeah. Okay.
That's equal to the rate of the boat plus the rate of the current times time. And
yeah.
This is where I was going wrong before. I was trying to say that 48 was equal to r sub c plus 16 times time.
Yes.
And that's not correct, because r sub b is r sub c plus 16, but you have to add the rate of the current to that.
Uh-huh.
So, in other words, when you're going downstream, it's the rate of the boat plus the rate of the current.
Okay.
Which means 48 equals, well, r sub b is the rate of the current plus 16 plus the rate of the current.
Yes.
So that's the equation we have when we're going downstream. Now when we're going upstream, we can go 32 miles an hour. Well, that's going to be the rate of the boat, which is that, minus the rate of the current.
Yeah, exactly.
That. Well, notice that the r sub c cancels out, and you end up with t equals 2.
Yeah.
Well, if t equals 2, we can go back up here and figure out what r sub c is. Because this equation, okay, so we've decided that t equals 2. Now we want to solve for r sub c.
Uh-huh.
So we got 48 equals 2 r sub c plus 16 times 2, because we know that t is 2.
Yes.
And that's going to let us solve for r sub c very easily. In other words, 2r sub c plus 16 equals 24. 2r sub c equals 8. The rate of the current equals 4 miles per hour.
Huh.
Now, the very first thing that I notice is that that is a reasonable rate. If you remember the way I did it the first time, I got the rate of the current was 80 miles an hour.
Uh-huh.
That's not a reasonable rate.
Gotcha.
Unless you got a tsunami. So always try to figure out if your answers are reasonable or not. Now, let's see if that makes sense. If the rate of the current is 4 miles per hour, well, we know the rate of the boat is 16 miles per hour more than that.
Yes.
So it's going 48 miles. The rate of the boat plus the current is R times 2 hours. That works. Now coming back, we got 32 miles. And that's equal to the rate of the boat minus the rate of the current.
Yeah.
Well, the rate of the boat minus the rate of the current is 16. So again, time equals 2 hours in both cases. That means that we've got the right answer.
Okay.
In other words, last night when we did this, I came up with a rate of the current of 80 miles per hour, which made the rate of the boat 96 miles per hour. Nothing made sense.
Yeah.
And it's, like I said, this is a bit of an optical illusion problem. It's really, really easy to say D equals the rate of the boat plus 16 times time. Because when you're going with the current, you know, you get a little bit extra from the rate of the boat, right? So it's easy to make that mistake, really easy. In fact, so easy that even in an hour last night, I could not figure it out. How I was making the mistake. But I had a little bit more chance to think about it today, and I figured it out.
Good.
Now, the other one that we had problems with, this one. We wanted to write the trigonometric function.
Yeah.
Like that, right?
Uh-huh.
Well, I had you do all the numbers on your calculator, and we could not come up with a correct answer.
Yeah, exactly.
So I did it today, and I had no problems at all. So I want to make sure you know how to use your calculator. You got a TI Inspire, right?
Yes, I do.
Okay. So, what's R? Tell me what R is.
R is the square root,
Yep.
of 5 minus 12 squared?
No, 5 squared plus minus 12 squared. Always. In other words, R is the square root of x squared plus y squared. Even though this is not x and y, this is a and b. This is a complex number.
Yes.
You can think of it as x and y.
Okay.
So R is the square root of that, which makes R equal to 13. Now, what is theta? Because that's the next big question we have to answer.
Yeah.
Well, theta is b over a if a is greater than 0, and it's b over a, excuse me, hold on, let me back up a second here. Tangent of theta is b over a. If you plot, let's plot this point in the complex. That's the real, that's the imaginary. Okay, so we're at 5 minus 12. We're way down there. Okay,
Yeah.
that's 5
Yep.
comma minus 12. Well, if I draw a line from the origin to that, and I call that theta, like the reflex angle in trig, well, then the tangent of theta equals the y-coordinate over the x-coordinate. Right? Only in this case, it's not y over x, it's b over a.
Okay. It's b over a, not y over x.
Yeah, in other words, this is b, and that's a. Okay?
Yeah.
And if it was x and y, you would take the inverse tangent of y over x. But it's b and a now. And this is another one that's a little difficult. Theta ends up being the inverse tan of b over a. That makes a lot of sense, okay? If tangent of theta is b over a, then theta is the inverse tangent of b over a.
Yeah.
But that's only if a is greater than 0. If a is less than 0, then it's the inverse tan of b over a plus pi. This is maybe one of the hardest things to understand.
Yeah, exactly.
You don't need to understand it. That's the thing, is what I'm saying. And this is true with a lot of math, is that you don't really need to understand it. You just have to do it. In other words, just do it. In this case, b is negative and a is positive. So it's this case. Okay? Now, I want you to do this in your calculator because I think that was the problem we were having.
Okay.
Last night.
Yeah, just give me one sec.
I think I have a reason why we may have been having a problem.
Okay. Yeah. My bat. Oh, fudge. I'm sorry. My thing ran out of battery.
Do you have your charger?
Not with me. Is there any chance you have a TI Inspire or?
I do. The problem is that when you did it on your TI Inspire last night, you got the wrong answer. So I wanted to make sure you can do it right.
Yeah.
And I believe the reason you got the wrong answer is because you used the wrong negative sign for 12. You have your
Really?
You have your TI Inspire in front of you?
I do. Yeah, it's dead, and I don't know where the charger is.
Notice there's two negative signs on there.
Yeah.
There's the one all the way on the right-hand column, and then there's the one below the 3.
Yes.
It's the one below the 3 that you want to use.
Okay.
That's a negative sign. The other one is subtraction. Well, we're not subtracting anything here. So all we're doing is taking the inverse tan of minus 12 over 5.
Yes.
Always going to give you a negative angle. And in this case, negative 67 degrees.
Huh.
So now the problem is verifying this.
Yeah.
We know the answer is negative 67 degrees. We know that R is 13. So, is this a true statement? In other words, is 5 minus 12i equal, well, we figured out R was 13. We know theta is minus 67 degrees. Is this a true statement? And it turns out that it is.
Good.
Yeah, if it does not turn out to be true, then we've got the wrong answer. And what happened last night was it did not turn out to be true. In other words, here's what happens, has to be. That has to be 5.
Yeah.
And 13 times I sine of minus 67 has to be minus 12i. And it is. If I multiply 13 times the sine of minus 67, I get 12. Just like if I multiply 13 times the cosine of minus 67, I get a positive 5.
Uh-huh.
Okay? So the fact that I can prove my answer is correct is important. And means that this is the right answer. And incidentally, this is the right answer, not this.
Okay.
This merely proves that we did it right. It's not the answer. The question was, put it in trigonometric format. That's trigonometric format, right there.
Huh.
In other words,
what is it? I have one that's below it that says convert 7 CIS 210 degrees to rectangular form. So is the 7 CIS 210 degrees, is that polar?
No, you're talking hyperbolic functions now, which is totally different. That's a whole new area of math. Yes. We've never talked about. Well, let's be done with this problem.
Okay.
Now let's go on to the next. All right. Now, here's what I have from last week, and this did not have the complex number converting, so we're probably done with this page. Am I correct?
Yes.
Antilog? I've never heard the expression antilog, ever.
Huh?
What the hell do they mean by antilog?
I do not know, honestly.
Wow. Okay. Did you send me something else?
Yes.
All right. Let me see if I got it. I do. Antilog. That should be relatively easy to figure out, but I've never heard that expression. So,
The ones I had circled are the ones that I wanted to work on.
all right. All right.
I think especially number 28, because those ones seem to be just giving me extra trouble.
All right. 28's easy. We'll make sure we cover 28 before we quit tonight. Let's start with 20, though.
Okay.
All right, so here's what we have. We have tangents, and the only reason I say that is because 20 looks kind of hard.
Uh-huh.
So I want to start with the hard ones first.
Okay. Tangent.
And the reason it looks hard is because it's two different trig functions.
Yeah.
Well, let's turn it into one trig function. What is tangent equal to?
Sine over cosine.
Okay. Notice how that's going to help. When I multiply it by cosine, I'm going to end up with sine only, right?
Yeah.
Now, the fact is that I have a binomial times a binomial. So I have to do this just like I would multiply a plus b times c plus d. Got to FOIL it. What's this term times this term?
Wait, I'm sorry.
FOIL these two terms. Multiply them by foiling. Or, if you're not familiar with the word FOIL, every term by every term.
So
Multiplying
sine x plus cosine x.
Next term, do that. Always. In other words, always maintain the same methodology. Don't switch around.
Okay. Minus cosine x over 2.
Well, that becomes minus 1/2 sine x over cosine x.
Oh.
What's the next term?
Then you have cosine x times plus 1.
So plus cosine x. And what's the last term?
Negative 1 times negative 1/2, which is negative 1/2.
Okay. So that's what we have. Now, that doesn't make things very much easier. So what that doesn't make things easier at all.
No.
Let me go back for a moment. Look at the problem again. Tan x plus 1 times cosine x minus 1/2 equals 0, given that x is between 0 and 2 pi. Alright. I love these kind of problems because they're tough. But sometimes they're too tough. Maybe the way to do this is not the way I did it, which is to convert tan x to sine x over cosine x.
Yeah.
When I did that, I did it because it looked like, well, I was going to end up with a sine x. And gosh, if I can get the whole trig function in terms of sine, I'm home free. But I did not get the whole trig function in terms of sine. I got a sine. That's actually tangent, and that's a cosine. And yeah, I don't see where I can go from here. So, let's go back to the beginning. What else could I do here?
Could we do one like tangent?
I'm done.
Like
Hold on.
X.
Hold on. I was just overlooking the obvious here. I immediately assumed that I wanted to multiply it together, but that's not what you want to do. I've got two things multiplied together that are equal to 0. That tells me that either tan x plus 1 equals 0 or cosine x minus 1/2 equals 0.
Yeah.
That's the first rule of algebra, and I mean the first rule. If somebody ever asks you what's the fundamental rule of algebra, this is it. If you have two things multiplied together equals 0, then one of them has to be 0.
Yeah.
All right, so now problem's relatively simple. We're inside the unit circle. Where is tangent? This means tangent of x equals minus 1. Well, what angle is tangent equal to minus 1?
What angle?
Let me ask you this. What angle is tangent of x equal to positive 1?
That would be 45 degrees and...
Very good. Hold on. Stop. Now, where is it equal to minus 1?
Where is it equal to minus 1? 135 and 315.
If you put it into your calculator, it's going to tell you minus 45 degrees, which is the same as 315. So you're right on your 315. Unfortunately, your second quadrant angle is not right. In other words, yes it is. My mistake. 135 is correct also. So those two are where tangent of x is equal to minus 1. Now, let's solve the other one. Where is cosine of x equal to 1/2? What two quadrants?
60 degrees and 300 degrees.
Very good, Justin. Crushing this trick stuff. So there's the four answers we have. X is equal,
Simple.
and you could even give an answer of minus 45. But minus 45 is the same as 315. Okay. So probably the desired answers are 315, 135, 60, and 30.
Yeah.
Now, how did I go wrong on this from the get-go? I just assumed when I see a trig equation with two different trig functions, my first instinct is to try to convert them all into the same trig function. And I knew that tangent was sine over cosine, and wow, that's going to get rid of the cosines, I'm going to have a sine. What I didn't realize is that was going to give me 3 trig functions, not just 2. So that's definitely not the way to go. And I overlooked the obvious, which is A times B equals 0. That means either A equals 0 or B equals 0. Both have to be true, but one of them does. And in our case, they both were true. Usually both of them are true.
Okay.
Okay. All right. $24.
Yes, please.
The next one that's circled. All right. So here we have the log of x plus the log of x equals the log of 4x minus 3. Well, whenever you see two log functions added together, you should think, can I combine that into one log function?
Yeah.
Okay, what is it?
2x equals 4x minus 3.
Not quite. Remember that when you're adding log functions, it means the arguments are being multiplied.
Oh, so x squared.
Exactly. So that's what the left side is the natural log of x squared. Now that's equal to the right side. Now you can equate arguments. So now I can say x squared equals 4x minus 3. Solve that.
X. Wait, so then it'll be x squared minus 4x plus 3 equals 0.
Factor.
X minus 3 times x minus 1 equals 0. So then x would equal 3 and 1.
Now we have to check the original function to make sure we don't violate any domains. And we don't. Neither 1 nor 3.
Yeah.
1 comes close to violating that domain, but not quite. In other words, we still have 4 minus 3, which is a positive number.
Because you can't have that equal 0 or negative, or be a negative number?
You cannot have the argument. You know what I mean by the argument? This is the argument, that's the argument, that's the argument.
Okay.
You cannot have the argument be negative or 0, ever.
Ever?
Ever. You cannot take the natural log of a negative number. You cannot take the natural log of 0.
Okay.
It's like taking the square root of a negative number. You can't do that either.
Gotcha.
Now, if we include complex numbers, then different story. In other words, you can take the natural log of a negative number, but you get imaginary solutions, which they don't teach you about in high school, which I find kind of interesting, because they do teach you that the square root of a negative number is an imaginary number. They teach you this.
Yeah.
But they never teach you that the natural log of a negative number is also an imaginary number. But it is. But you'll also notice that even though they teach you that the square root of negative 1 is I, they still, if you said, what's the square root of x, what's the domain has to be greater than or equal to 0.
Yeah.
In other words, that's true. The domain does not change. The fact that we can take the square root of negative numbers and get imaginary numbers does not affect the domain of the function, nor is the natural log function affected by that either.
Really?
In other words, the domain is the domain. It is always has to be a positive number. And it doesn't matter if you're natural log or any base log. You cannot take the log of 0. You cannot take the log of a negative number.
So you can only take the log of a positive number.
Exactly.
Okay.
Not 0. All right.
Gotcha.
So, 25. 3 log base 7. And all of these log rules apply only if all the logs are the same base. Like this. In other words, if one of these was a base 9 or something, then you cannot use any of those log rules. But since they're all log base 7, then I can. Well, what's the first thing to do?
Let's see. Condense it. So like,
yes.
Log 3x cubed equals, log 7x cubed equals log 781 minus log 7 3.
not minus.
Divided by?
Yeah. In other words, when you're condensing, you never do the same thing that the function is doing.
Okay.
The function is subtracting. Therefore, my argument needs to be division. If the function was adding, then my argument would be multiplication.
Yeah, exactly.
Okay, so and
addition is multiplication. I know this sounds kind of weird, but it's like addition is multiplication and subtraction is
division. Exactly. Is all you have to really remember is that you never do the same. In other words, if my argument is division, I'm never dividing the exponents. If my argument is multiplication, I am never multiplying the exponents.
Gotcha.
Okay, so 81 is divisible by 3. That's 27. So now I have the log base 7 of 27. Now what can I say?
X cubed equals 27.
What's x equal?
3 or positive. Positive or negative 3?
Positive only.
Oh, just positive?
Well, notice that negative doesn't work. Negative 3 times negative 3 times negative 3 is negative
yes.
7.
Yeah.
So when you have odd exponents, you don't have plus or minus answers. You get plus or minus answers when you have even exponents. Remember that I've told you that if you ever have to solve a problem by taking the square root of both sides, always begin your answer with the words plus and minus? Well, we're not solving this by taking the square root of both sides. We're solving it by taking the cube root.
Yeah.
And when you take the cube root of 27, it's 7. It's not, or 3. It's not plus or minus 3.
It's only the square root?
Well, let's go over this. This is important. If I say x squared is 4, then x is plus or minus 2.
Yeah.
Because minus 2 times minus 2 is equal to 4. So is plus 2 times plus 2 is equal to 4.
Okay.
But if I have x cubed equals 8, then x is only equal to 2. If I had x cubed equals minus 8, then x is minus 2. So when you have odd exponents, you do not have plus or minus answers. You have either plus
even exponents.
It's only even exponents, and it doesn't have to be 2. It could be 4. If it's 4 or 6 or 8, your answers are always going to be plus or minus.
Yeah.
But when it's odd, your answers are either plus or minus, depending on what that is. If that's a minus 8, then the answer is minus 2. If that's a plus 8, then the answer is 2.
Okay.
Okay? Now, let's go back to our problem. The one thing we didn't do was check to make sure we're not violating the domain. So we got x equal 3 was the only answer. Well, that does not violate any domains. So we're fine.
All right.
27.
$27.
Is that the next one, or 26? I notice right now that 26 was circled also.
Let's do 26. Let's just make our way down. 26, 27, 28.
I think that that's a good idea, especially if you circled them at one time. That means you didn't understand them totally. What's that equal to?
Would that be equal to 2 cubed?
It's equal to 3.
Wait, but why? Oh, because the log 2 and the 2 cancel out.
Exactly. If I have this, b
Booyah.
log base b of x, that's always equal to x. In other words,
Yes.
these two cancel out.
Okay.
Okay? So, I know that that's going to equal 3, but let's keep going. Minus 3 times 2 log base 3 of 2. What's that equal to?
Would that be 2 squared, so 4?
Beautiful.
Sweet. Let's go, team.
5 log base 5 of 4 plus log base 5 of 6. What's that equal to? Simplify that first.
Would that be 4 times 6?
So it's log base 5 of 24. Right?
Yeah. Yes.
Okay, now what is 5 to the log base 5 of 24 equal to?
Just 24?
Good. And finally, we have minus 4 times common log of 10 to the 5th. What's that going to be equal to?
Yeah. Oh, that looks kind of funny though. 10
Get
4 times 5.
rid of the leading coefficient. Make it an exponent.
Okay, would that be 10 to the 4th?
I think it's actually 10 to the 20th. In other words, here, if I talk about just this expression right here, if I want to bring that up there, then it's got to be like this, right?
Yeah.
Well, now I multiply exponents. I've got double exponentiation going on. So that's the log of 10 to the 20th. Well, the implied base here is 10, right? In other words, if they do not write a base, it's 10.
Okay.
So what's that equal to?
10 to the 20th. Would that? Oh, fudge! That's big.
No? It's
Or
not.
is it? Wait, why would it not be big? Is it just 20?
Uh-huh. It's just 20. So that's what this term is 20. And it's plus, correct? Hold on a second. No, it's minus. So it's minus 20. So this becomes 3 minus 4 plus 24 minus 20. So that's 3.
Would that be 3?
That'd be 3.
Okay.
That's the answer. All right, 27. Hold on.
27. I tried to do this one and it ended up pretty funny, so
Okay.
I'm not quite sure.
Well, let me put this on my screen. I think it'll be better. So first of all, let's graph the two equations. If you don't know what to do, that's always a good thing to do. Especially when the answer says, or when the question says, shade the regions that satisfy the inequalities. Okay. Notice one function is our first y, and the other function is our second y.
Yeah.
All right. So let's graph the first y. How do you graph y equals x minus 3 squared plus 2?
So would the starting point be at 3, 2?
Yeah, that's the vertex. Okay, I'll go for that. That, in other words, it's kind of in vertex format, right?
Yeah, exactly.
It's in perfect vertex format. X minus 8 plus k. So yeah, the vertex is 3, 2. Does it open up or down?
Up.
So there's our first function. I was going to have you plotted as a transformation of the other function, but this works just as well. Now, how do I plot y equal x squared? Where's that vertex?
Vertex is just at the origin, right?
Huh?
And then you just go to like 1, 1, 2, 4, 3, 9.
Well, hold on a second. I've got to satisfy these following equations. The first one is y is greater than the equation, greater than or equal to the equation on the right. So how do I shade that? What part of that do I shade? Above the parabola or below the parabola?
Above.
Okay, so in other words, that whole area.
Yeah.
That's what it means when it says y is greater than that. And it's a solid line because it's greater than or equal to.
Yeah.
Now, the second one says y is greater than x squared. Well, immediately that means it's a dotted line. So let's make it a dotted line. Where's that shade? Above or below?
Above, too.
Exactly. And this time I'm going to shade it with vertical stripes. And then the area that is in common is this area right here.
Yeah.
And that's the answer. And that's the only answer. In other words, I can give two answers to this problem. I can give a graphical answer, or I can give a numerical answer, which is what they give you on the page. But they ask for a graphical answer. Shade the region that satisfies those inequalities. So you have to give a graphical answer here.
Okay.
All right, 28. 28.
Okay, so I've been messing up on these ones all the time, so.
Well, this is actually pretty easy. Let me.
All right.
Think Pythagorean theorem. Okay. What's the area of a right triangle?
Of a right triangle? Area base times the height. Or, I mean, what the? Base times height divided by 2.
Okay, this is not a right triangle.
Yeah.
So it's 1/2 base times the height, which is not even the vertical height. In other words, it's 1/2 of one side times the other side times cosine of the angle between them. Now, hold on, I gotta look that up. Sorry, hold on.
You're good. No worries.
I for some reason, there's certain trig functions that I do not memorize well. One of them is the area of a triangle. For some reason, I always have to look it up. I don't know why. The brain operates in strange ways. Area of triangle 557. I don't know why this gives me problems. It's 1/2 AB times the sine of the angle, not the cosine.
Okay.
And when I say AB, it's not base times height, really. In other words, you understand that the height is not 40 centimeters here.
Yeah, I do.
Just the other side. Okay, so really what the formula is, it's not base times height, it's the two sides that you know, which are A, actually it's B and C. So it's really 1/2 B times C times the sine of A, right? In other words, this is the general formula. It's always the sine of whatever that is. And there's 3 of them. In other words, the area can also be equal to 1/2 A times C times the sine of B. And the area can also be equal to 1/2 B times C times the sine of A. Notice the pattern?
Yep.
Okay.
I do.
So, what we're dealing with here is really simple. In other words, it's 1/2 40 times 28 times the sine of 135 degrees. Is the sine of 135 degrees positive or negative?
It is positive.
Better be, right? Otherwise we got a negative area, which you cannot have. So the sine is positive in the first and second quadrant. And with any triangle, the biggest angle you can have is 179 degrees, right?
Yes.
So that means the sine of that angle is always positive. So you always have a positive area. And I should remember that when I'm trying to memorize this, because that means it can never be cosine. Because cosine of second quadrant is negative.
Yes.
So if that were a cosine, I would sometimes end up with a negative area. You can't have a negative area. So the fact that sine is positive in the first and second means that's always going to be a positive number. And is all you need to memorize is the equation.
Okay.
The general equation.
I have 395.98. Does that sound okay, or?
Well, let's see. What do we have? We have 20 times 28, which is 560, times the sine of 135, which is the same as the sine of 45, which is root 2 over 2. So now I have 280 root 2. Well, root 2 is 1.4, so I would say 400 and something. What'd you come up with?
I got 395.
That's fine. 280 times root 2 is probably 395.
Okay, good.
Yeah.
Yeah, 395.98.
Certainly a ballpark answer. In other words, it's always good to have a ballpark answer. You know what I mean by that?
It's close enough.
No. If you'd have come up with an answer of 7, could that have been right?
Well,
Not really.
no, not really. No.
If you'd have come up with an answer of 7 million, that could not have been right either.
No.
So when I say a ballpark answer, I mean, are we within a magnitude of 10 error? And
Yes.
yeah, we are. In other words, 400, approximately 400 seems right. If I just do the approximation in my head without a calculator, it seems right. And that's the way you want to do ballpark answers, is kind of do an estimate in your head and make sure that you're within a factor of 10 of that.
Okay.
All right. We got 3 minutes. Let's do 29.
Awesome. Is this one like the one where you use the quadratic formula?
Perfect. What is the quadratic formula?
X equals negative b plus or minus the square root b squared minus 4ac all over 2a.
You're the first person I have ever had sing it to me.
That's the only way I ever think of it.
That's the only time I've ever had the song. Let me see if I can repeat that. Minus b plus or minus the square. I see I can't even do it. I've never heard the song before. Say it again.
X equals negative b plus or minus the square root b squared minus 4ac all over 2a.
X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Like that?
Yeah.
Kinda? Okay.
Kinda.
It'd be nice if I could remember it, because I get a lot of students that can't remember this thing, and
Yeah.
I always wanted a song. In other words, the only way I still remember the ABCs is by that song. A, B, C, D, F, G, H, I, J, K, you know. If I didn't have that song, I wouldn't be able to memorize my alphabet to this day. Okay, so what is X going to be here? Fill in the blanks.
Let's see. X. So negative b is going to be, well, let's see. Hold on. A is 1. B is negative 4. C is 6.
Okay.
So negative b is going to be negative 4, which will be 4.
Okay.
Plus or minus the square root. That would be b squared is negative 4 squared minus 4 times 1 times 6. So it would be 16 minus 24. All over 2.
Okay. They already gave us an idea that we may be having complex numbers because they've suggested that. So
Yeah.
we're not surprised that we're taking the square root of a negative number. Simplify, what's the square root of negative 8 equal to?
The square root of negative 8 would be 2 root 2. No. Yeah, 2 root 2.
That's the square root of 8. So the fact that it's a negative sign in there means what? 2 root 2 I.
That would be 2 root 2 I.
I, exactly. In other words, here's why. Because negative 8 is equal to the square root of negative 1 times the square root of 8, right? That's always the first step you want to make, always. That we know is I. Well, square root of 8 is 2 root 2. So it's 2 root 2 I. You always put the I last. So now here's what we have. 4 plus or minus, this is 2 root 2 I And we're all dividing by 2. Simplify that one more step.
2 plus 2 root 2I.
Almost.
2 plus or minus.
Plus or minus, but it's just root 2I. Is that
Yeah.
what it said? Okay. Yeah, because I can divide that by 2, I can divide that by 2, and I can divide that by 2. And that gives you that. And that's the answer.
All right. Booyah.
All right, Justin. I will talk to you next time.
Sweet. I think we have Wednesday.
Yeah, I guess. I don't know. I'm 2 minutes late for my next appointment, so I'm going to run. You want me to look real quick? Let's see. Yeah, Wednesday at 7. Nothing tomorrow.
Gotcha.
Okay.
All right. Oh, sweet. Yeah. You better get to Dylan.
All right. Talk to you